Hola, buenos días. Hoy empezaremos con la sección 10. Why am I talking in Spanish? I'm losing my mind. Anyway, we are beginning the next section, 10.2, and it is arithmetic sequences and series. Series, this is the new stuff right here. We already know about arithmetic sequences, and we're going to be learning from the book. Let's jump right into it. Here's the first page of section 10.2. Let's get our notebooks out, and you know what, even before beginning this section, let's review. Let's put a title on here. There's my title, 10.2 Arithmetic Sequences and Series. Please don't forget to put a date and day over here. And let's begin by reviewing. What did we learn about in the previous section? We learned about arithmetic sequences and also geometric sequences. And what is a sequence? It's just a list of numbers, and of course they have patterns, right? What identifies or what determines whether a sequence is arithmetic? An arithmetic sequence has a common difference. Okay, and a geometric sequence has a common ratio. So, and I hope we remember that the common difference, they use the variable d to denote common difference, and common ratio, they use the variable r to denote common ratio. And again, reviewing, if you did have a list, like let's begin with this list right here, 5, 7, 9, 11, 13, and that's a sequence, that's a list of numbers. And we talked about the notation. If you wanted to talk about the third number, the number 9 on this list, you could refer to that as a sub 3. Okay, that's just the position. A sub 3 means the third number. Likewise, a sub 1 would refer to the number 5, a sub 2, a sub 4, a sub 5. This is all just notation, so we know what we're talking about. So if I tell you find a sub 7, then that would mean the 7th number on this list. So you'd have to continue with whatever pattern's going on. And this, of course, is an arithmetic sequence. Why is that? Because there's a common difference between all the terms, right? 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13. So if you wanted to find a sub 7, well, you'd have to continue to add 2. 13 plus 2 is 15, 15 plus 2 is 17. So a sub 7 equals 17. So I hope we understand the notation, and I hope we understand that this sequence is arithmetic. Why? Because there's a common difference. And again, I don't want you to think, oh, 5 plus what will give me 7. The proper way, or the best way to figure out your common difference or your common ratio, is to pick a number and then subtract the previous number from it. So if you did go 13 take away 11, you'll get that common difference too. Or if you picked 9 take away 7, 9 take away 7, you get that common difference too. Okay, whichever ones you pick, right? Any numbers you pick. If you pick 7 take away 5, you're going to have that common difference too. So yes, of course, on this arithmetic sequence, the common difference is 2. Why do I recommend you do that, where you pick a number and subtract the previous one, instead of just thinking, oh, 5 plus what is 7? Because if you have fractions, if you have decimals, if you have negative numbers, it'll be a lot easier to figure out this common difference if you do this strategy of picking a number and subtracting the one previous of it, right? Likewise, if you had, let's go with another review problem here. Let's say you had 6, 12, 24. I'll go for another one, 48. This is not arithmetic, because if you go 48 take away 24, that's 24. If I go 12 take away 6, that's 6. And as you can see, the difference is not common, so it's definitely not arithmetic. Right here it would be geometric. Why is that? Because there's a common ratio. And again, if you pick a number, 24, and put it over the previous one, 24 divided by 12, that becomes 2. Or how about this, 48 divided by 24, 48 divided by 24, that is 2 also. Or how about this, 12 divided by 6, 12 divided by 6, that is 2 also. So right here on this sequence, it's not arithmetic, it is geometric. Why is it geometric? Because it has a common ratio r, which is 2. And that explains how it grows from this one to this one, or how it decays from this one to this one. Right here, it's growing by 2. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. I know some of us are thinking, well, I could already see that 6 times 2 is 12, and 12 times 2 is 48. So that's how I'll determine what my r is. Yeah, you could do it that way. But again, if you have fractions, if you have decimals, if you have negative numbers, it could get weird. I highly suggest pick a number, divide the one right before it. Okay, pick a number, divide it by the one right before it. Make a fraction, reduce it. You'll be able to find your common ratio a lot easier. So anyways, section 10.1, we learned all about common ratios and common differences. And we know that arithmetic have a common difference and geometric have a common ratio. You need to remember that. Very important stuff. And on this section, 10.2, we are not, notice at the title on today's lesson, it doesn't say arithmetic and geometric, it just says arithmetic. We're going to focus in only on the sequences that have a common difference. Okay, we're not worrying about common ratio. We'll do that the next day or a couple of days from now. Right now, we're just going to focus on arithmetic sequences and series. We'll get to what a series is. Anyways, all of this was review, okay? This was all review right here. We're going to jump to some new notes in a little bit. Let's go back to the book. And in our book, let's jump right into the key concept, all right? What does this say on the key concept? We're going to write this down in our notes. It says the nth term, a sub n. Remember, a sub n is just the location. Is it the third number, the fifth number? In this case, they're saying the nth number. So they could be talking about the 20th, the 30th number, and they refer to it as a sub n, okay? The nth term, a sub n, of an arithmetic sequence in which the first term is a sub 1. We already knew that. A sub 1 is the first one. A sub 2 is the second one. And the common difference, d, we already know how to find the common difference, is given by the following formula where n is any natural number. This guy right here, this is what we need to memorize right here, guys. This is the a sub nth rule for any arithmetic sequence. Let's go to our notebook and jot that in. So here's our notes. Please write this down. A sub nth rule for arithmetic sequences. And let's write down, and as we write down, begin memorizing this rule. Okay, so what is the rule? If you want to find any number on your list that's an arithmetic sequence, you're going to have to apply this formula that you're about to memorize. And the formula always begins, kind of like the list begins. The list begins with the first number, which is called a sub 1. Okay, so the formula begins with a sub 1. And in an arithmetic sequence, you're usually adding either a positive number or a negative number to get to your next number, right? Like if you have 2, 4, 6, 8, you're adding 2 to each one. Or if you have like 5, 10, 15, 20, you're adding 5 to each one. So any arithmetic sequence, you're going to be adding something. So that's why you begin with a sub 1, just like an arithmetic sequence begins with a sub 1. You are adding. Now this is the more challenging part to memorize. You're going to be adding something in parentheses. And in those parentheses, you'll have n minus 1 times the common difference d. Okay? So this is the formula we have to memorize. And if you want, let's just jot down some notes right here. We could put first number on list. Right? That's the a sub 1 right there. The common difference d, common difference, will be this d variable right there. And what about n? What is n? Well, again, this is the rule. This is the formula that we're going to use to find maybe the third number or the 17th number or the 20th number. So if you have a list, let's say you have like 4 or 5 numbers, and I tell you find a sub 7, you already know that means find the 7th number on that list. So if I do ask you to find a sub 7, then that would mean that the 7 would go right in here where the n is at, okay? The n is just which number you're talking about. Now I know that this might seem confusing right here because there's so many variables, there's no numbers yet. Let's actually see it in action. Down here in the book, they give you, the beauty of the math textbooks is that they give you some notes, they give you examples, and they show you, they explain how they actually do it. So right here on this example number 1, they want you to find the 12th term of the arithmetic sequence 9, 16, 23, 30, okay? So imagine that. I want to find the 12th number. So what if I told you which one is a sub 3? I hope you guys recognize that a sub 3 is just really the number 23. Likewise, a sub 4 is 30, a sub 2 is 16, a sub 1 is that first number 9. So we need to be comfortable with the notation. Let's begin with that. They tell us that it's arithmetic. All right, now what does that mean that it's arithmetic as opposed to geometric? Arithmetic means that there's a common difference D. What is that common difference? Well, again, pick a number and subtract the one previous from it, okay? So let's write that out. 30, take away 23, that will give us 7. That means that the common difference is 7, okay? So we understand that this is an arithmetic sequence because they tell us that. If you wanted to, you could go 16 take away 9 at 7, 23 take away 16, that's 7, 30 take away 23 at 7. Of course, it's common because it's arithmetic. There's a common difference. Okay, anyway, let's write down the formula. And the formula that we need to memorize is, again, a sub n equals a sub 1 plus parenthesis n minus 1 times the common difference d. So the thing is, for us to get this formula, we need to have these missing values. We need to be able to get a sub 1 and plug it right in here, common difference d, plug it right in there, and we will actually get a machine that produces this list. So what is a sub 1? As you can see, a sub 1 right here is 9. Okay, so we're going to begin by putting in a 9 right here where the a sub 1 is at. And then let's continue to put everything else. We have a plus, we have parentheses, we have n minus 1, close parentheses, and then that common difference d, which we said was 7, right? 7, so let's put a 7 over there. And this is a sub n. A sub n equals that stuff, okay? Now, I know you guys are thinking, what does he mean, a sub n? It's the name of the function that'll allow us to produce this list. In a couple of seconds, it'll make total sense. You see, right here, we have a math problem that could be simplified, right? There's distributive property with that 7, and there's also combining like terms after you distribute. So let's do that. Let's go 7 times n, that's 7n. 7 times negative 1, that's negative 7. Bring down the plus, bring down the 9. And we do have 3 terms, and out of these 3 terms, we could combine the 9 with the negative 7. And 9 minus 7, that is 2. So let me rewrite this whole equation. A sub n equals, we said 9, take away 7 is 2, but I'm going to put this 7n first, positive 7n first, and then the positive 2, when I go 9 take away 7, we get a positive 2. We end up with this equation. A sub n equals 7n plus 2. Now, here's the crazy part, right, guys? We have just, by analyzing this list, we have created a function machine. This is the machine that'll produce this list. What the heck is Salgado talking about? Now, check this out. A sub 1. What is a sub 1? A sub 1 is the first number. What is the first number? It's 9, okay? So imagine that. If I said a sub 1, that's saying that instead of this n, I put a 1. We already know that the number's 9. But if I say a sub 1 equals 7, well, if I put a 1 right here for a sub 1, then there's going to be a 1 right here. 7 times 1 plus 2. What's 7 times 1? That's 7. What's 7 plus 2? That's 9. Amazing, right? This is the machine that'll produce this list. Believe it or not, if I plug in the number 1, I'll get this first term 9. If I plug in the number 2, 7 times 2 is 14. 14 plus 2, I get the second number 16. Plug in 3, I'll get the third number. Plug in 4, I'll get the fourth number. This is the machine that created this list. All right? I know, your minds are blown. I know, you want to share it with the world, right? Go ahead, tell your parents or your friends. I don't know. Well, your friends, you could text it to them, I guess. Okay, I'll shut up. My point is, this, by memorizing this formula right here in our notebooks, we have it, you'll be able to create or find the machine that produces the list, the function machine that produces the list. Now that is amazing. Why is it amazing? Because you could find any number you want. What does it say right here on the original question? It says, find the 12th term. So what does that mean? They want you to find not a sub 1, not a sub 2, not a sub 3. They want you to find a sub 12. So if you already have this machine right here, you could actually find a sub 12. Let me do the 12 in a different color. A sub 12. You could actually find a sub 12 by plugging it in. All right. Now, this is just the notation. This is just the name of it. This is saying that you're going to find the 12th number. What is the 12th number? Well, you're going to have 7 times 12 plus 2. The 12, all you do is plug it right in there. Again, if you replace that n with 12, that means you're going to replace the n with 12. And now multiply it out and work it out. 7 times 12 is 84. So you really have 84 plus 2, 86 is your answer. Answer to what? It's saying a sub 12 equals 86. What does that mean? The 12th number on this list will be the number 86. As you can see, it's growing, right? It's growing by 7. 9 plus 7 is 16. Plus 7 is 23. Plus 7 is 30. Keep going. Plus 7 is 37. Plus 7 is 44. If you keep going all the way to the 13th number, it will be 86. And it's a heck of a lot easier to use this function, right? Once you get your information, you create your function machine that produces the list, and then you could get your 12th term 86. Some of us are thinking, well, why would I want to do all this math when I could just keep adding 7? Adding 7 is simple. Well, yeah, but what if I told you find the 83rd term? Forget that. That'd be crazy, right? As opposed to, I mean, it'd be easy if you have this. The 83rd term, you just plug in 83. Do it with the calculator. 7 times 83 plus 2. Bam, you have your 83rd term of this list. Okay, I apologize. This video is getting long, but I hope we understand that. And that's what they show on this example 1. Okay, let's flip the page. Now, here's example 2. It's a different type of question. Actually, no, it's not. They want you to find the equation for the nth term. They want the a sub nth term. They want the machine that produces the list. So again, they're telling you that it's arithmetic. So they're telling you that there's a common difference. So how would you find that common difference? They're doing it for you right here. They go negative 13, take away 5. Again, negative numbers, positive numbers, the easiest way to find your common difference, or common ratio for that matter, is to pick a number and subtract the one before it, right? Now, if you're trying to find the common ratio, you'd go this one divided by this one. But right here, it's common difference because they're telling us it's arithmetic. So negative 13 take away 5, that's negative 18. Or negative 31 take away a negative 13, that becomes plus 13, that's also negative 18, the difference. So the common difference, they even show you the work here, is negative 18. So once you have that common difference, and you know your a sub nth rule, that formula that we should have memorized, you're going to plug in your a sub 1 term right here. You're going to plug in your common difference d, which we said was negative 18 right here. And your first term is 5. That's why they plug in a 5. Your common difference is negative 18. That's why they plug in a negative 18. They distribute the negative 18. You end up with negative 18n plus 18 once you distribute that negative 18. Now notice that they keep the parentheses here, but it's a plus sign, and the plus sign doesn't change anything. So you could erase the parentheses, but you will have to combine the 5 plus 18, which is 23. And always write your variable term first. So you have your a sub nth rule being negative 18n plus 23. And again, this rule is great. This function machine that you just found out is great because you could find any number you want on this list. If you plugged in a 2 right here, a sub 2, then you'd plug in a 2 right here, do the math, it'll give you that answer, that second number, negative 13. If you plugged in a 3, it'll give you that third number. If they wanted the 15th number, plug in a 15, do it with the calculator, negative 18 times 15 plus 23, it'll give you the 15th number. Now, sometimes they'll give you a list and they want you to find that a sub nth rule. Sometimes they'll give you some information, all right? So they have a sub 5 equals 19 and the common difference is 6. Interesting. All right, so how about this? Let me zoom in right here and let me just cut this information out. So in math, they might not give you the information that you want, right? I mean, we want a sub 1 and we want the common difference. That way we could create our machine. But they don't give us a sub 1, they give us a sub 5. So in math, you always take what they give you, plug it in to find out what you really want. Now, let's begin by writing down our formula that we need to remember or memorize for the a sub nth rule of an arithmetic sequence. What is the formula? It's a sub n equals a sub 1, that first term, plus parenthesis n minus 1 times the common difference d. Do they give us any of that? Yes, they give us the common difference is 6, so we could at least put a 6 right here. We still have the parentheses, we still have the n minus 1, we have a plus. We don't have a sub 1, so I'm just going to rewrite a sub 1. We do have an a sub 5, which is 19. So how's that going to help us? Well, a sub n means any number on this list. So if we're talking about the fifth number on the list being 19, we're really saying that a sub 5, if I put a 5 right here, that would be a sub 5, which is really 19, right? So I'm going to do this. A sub 5 is really 19. That's where the 19 came from. Okay. So instead of a sub n, I wrote a sub 5, but instead of a sub 5, I really wrote 19. Now, you're probably thinking, well, why the heck did you even mention a sub 5? Well, it's important because 5 took place of the n, since we're talking about the fifth number, which is really 19. The fifth number is 19. But that 5 that took place of the n, you're going to have to take that place of that n, right? So you're going to have to put the 5 right there as well. So you really have 19 equals a sub 1, which we don't know what it is, plus, instead of n, we're going to put a 5 right there, minus 1 times 6. So again, we're plugging in what they give us to find out what we need, okay? Oh, wait a minute, I put d instead of 6, my bad. It's a little bit more challenging when I'm not in front of you guys. You guys usually catch all my mistakes. By the way, if I make a mistake on a video, please post it, let me know, or text me of my mistake. Now, some of us may think we're going to distribute the 6, but it's easier to do parentheses first. 5 take away 1 is 4. So let's rewrite the whole thing. We have 19 equals a sub 1 plus, that's really a 4, times 6. So you really have 19 equals a sub 1 plus 24. Let's get rid of the 24 to get a sub 1 by itself. So subtract 24, we get a sub 1 equals negative 5. So a sub 1 equals negative 5. Now, ladies and gentlemen, we have the a sub 1 value that we need, which is negative 5, and we have the common difference that was given to us. That way we could get the a sub nth rule. Okay, so let's take that negative 5 and put it right here. Take the 6 and put it right there, and we should have our a sub nth rule after simplifying it. Before I do that, I need to group everything. Okay, here we go. So the a sub nth rule will be a sub 1, which we said was negative 5, plus n minus 1 times the common difference 6. Distribute the 6, you'll get 6n minus 6. We do have a plus negative 5 out here in the front. So a sub n, a sub n is going to equal positive 6n minus 11. When I combine the negative 5 and the negative 6, we get a negative 11. This is the a sub nth rule for this problem up here. So let's just go back to our book to verify that. As you could see, they show all that same work right here, and they end up with that a sub nth rule being 6n minus 11. That's exactly what we have over here. A sub n equals 6n minus 11. There's definitely a lot more to this section, but I want to kind of break up this section into two pieces. So let's jump to the actual practice of these first two examples of writing the a sub nth rule. So let me go to page 670. This is where we're going to get our homework assignment for today. And let's focus in just on those example 2 type of questions where we create or we find the equation that produces the sequence. So your homework assignment will be to do numbers 20 through 23. That's right, just 20 through 23. And let's go through some examples. I'm going to do numbers 3 and 4, which are very similar to the ones you're about to do. Let me jot down number 3 in my notebook. And they want us to find the a sub nth rule. Now, what does that look like? The machine that produces this list that starts with 13 and goes on to 19 and 25. It looks like this. It's a sub n equals a sub 1 plus n minus 1 times a common difference d. So we obviously need the a sub 1 term, which is this one right here, the 13. And we obviously need the common difference d, this guy over here, which is found by simply picking a number and subtracting the one right before it. So if I went 25, take away 19, that'll give me 6. Or likewise, if I went 19, take away 13, that would also give me 6. So we know that the common difference d is 6. And again, we know that the a sub 1 term is that first number 13. So let's plug in the a sub 1, the 13. Let's plug it in right here, and let's put the 6 right there. So let's rewrite my a sub nth rule. A sub n equals a sub 1, 13, plus parenthesis n minus 1 times that common difference, 6. Now all you have to do is distribute and combine like terms. Distribute. Let me move this up first. Let's distribute the 6. So we have 6 times n, that is 6n. 6 times 1, that is minus 6. Bring down the plus and the 13. Out of those 3 terms, we could combine the 13 with the minus 6, and that will give us 7. So let's write our variable term first. Let's write the 6n first, and then write the positive 7 second. And of course, this is the a sub nth rule. This is the machine that produces that list. If you don't believe me, go ahead and plug in the number 1. So if you say 6 times 1, that's 6 plus 7, that is 13. If you plug in the number 2, it should give you 19. If you plug in the number 3, it should give you 25. 6 times 3 is 18. 18 plus 7 really is 25. That's just a way to double check to see if you actually got the right function that produces that list. Anyways, let's try number 4 from the book. So here's number 4. Let me jot it down in my notebook. There it is. And now let's remember that we're going to use the a sub nth rule that we have to have memorized. What is that? That's a sub n equals a sub 1. A sub 1 is the first number on your list, plus parenthesis n minus 1 times that common difference d. And we know that the d is negative 4, so we're going to be plugging in the negative 4 right in there. But we do not know a sub 1. We know a sub 5. This is the 5th number on the list, but we don't know a sub 1. So technically, just to give you a logical explanation, we don't know a sub 1. We don't know a sub 2, a sub 3, a sub 4, but we do know a sub 5. A sub 5 is actually this negative 12, okay? And they do give us a common difference of negative 4, which means that the next number, this next number over here, that will be a difference of negative 4, which would mean that you would have to go negative 12 minus 4 to get to this next one, which would be negative 16, and then minus 4, negative 20, and you could keep going to find other terms. Again, here's your a sub 5 term, here's your a sub 6, a sub 7, and technically you could work backwards to find your a sub 1. That might be, it might be easier, but we do want to encourage not using logic in this situation. We want to encourage using the algebra, okay? So let's plug in what we know to find out what we don't know. We want to find this a sub 1 term right here. We don't know what it is. Let's find that a sub 1 term. And let's use algebra. Let's plug in everything that they give us. You see, it says a sub n, which means any number on your list. And right here, they're talking about the 5th number on the list. So it'd be a good idea to begin by plugging in a sub 5, since that's what we're talking about. We're talking about a sub 5. So let me put a sub 5 equals, A sub 1, we don't know what that is, but we do have plus n minus 1 times a common difference d. Now, the reason why I put a sub 5 instead of a sub n is because they gave us a sub 5. So we're plugging in what they gave us. Now, we already know that a sub 5 is negative 12. So why didn't I just put a negative 12 instead of a sub 5? Well, I want you to clearly see that this little n changed to a 5. That's just notation. But that means that this n has to change to a 5. So what I should do is go back and erase that n and put that 5 right in there. And now that we know that the n is 5, now we could change this a sub 5 to become what a sub 5 really equals. It equals negative 12. So let's do that. Let's put a negative 12 equals a sub 1 plus, you might as well do this math, 5 take away 1 is 4, times a common difference d, but we said that that common difference is negative 4, so let's just put a negative 4 right here for d. Now notice that I did put the negative 4 in parentheses. If I don't put the parentheses, I might think that it says 4 take away 4. So I put the parentheses there to remind me that I'm multiplying, right? You're multiplying times d. So I put the negative 4 in parentheses so I'll remember to multiply. Anyhow, we have negative 12 equals a sub 1 plus 4 times negative 4. That's really going to be negative 12 equals a sub 1 minus 16. Or plus negative 16, but I like minus 16 better. Let's get rid of that minus 16 by adding 16, and we will get our a sub 1 value equaling positive 4. 4 equals a sub 1. Okay, so back to our original a sub n formula that we have to memorize for arithmetic sequences. We need two things to be able to write out our function that produces the list. We need a sub 1 and we need d. They gave us d, that was negative 4, and we need a sub 1, which we just found, a sub 1 equals 4. Okay, so let's write out our new a sub nth equation. A sub n equals a sub 1, which is 4, plus parenthesis n minus 1 times that common difference, which is negative 4. Plug it in right there. And after doing that, you need to distribute to simplify it and then combine like terms. So negative 4 times n, that becomes negative 4n. Negative 4 times negative 1 becomes positive 4. Of course, bring down the plus and the 4 that's in the front. Let me make some space here. Then from there, we have our a sub nth rule equaling 4 plus 4 is 8. But let's begin by writing the variable term first. The negative 4n, write that first, and then put the plus 8 at the very end. Ladies and gentlemen, that is the equation that will produce the list that we have. And you're probably thinking there is no list, and you're right, there was no list. But we did have the fifth term, which was negative 12. So if you did plug in 5, you should get the answer negative 12. And if you verify that, negative 4 times 5, that's negative 20. Negative 20 plus 8 really is that fifth term, negative 12. Okay, so we understood, I hope we understand how we found the a sub 1 term by plugging in everything that they gave us to find out what we needed. And then we plugged in the a sub 1 right here and the common difference d right here, simplified. We have our machine that produces the list. Now, let's go back to this original logical situation. They gave us the a sub 5, which was negative 12. We know that the common difference is negative 4, so from here to here, you have to subtract 4 from it. So negative 12 plus a negative 4, that's negative 16, and so on. So if you subtract 4, that's how it grows in the negative direction. If you're going in the opposite direction, you should be adding 4, right? If you go negative 12 plus 4, that's negative 16, plus 4 is negative 12. If you wanted to, you could go plus 4, that's negative 8, plus 4, that's negative 4, plus 4, that's 0, plus 4, that's 4. So a sub 1 is 4. And that's doing it logically. Here is algebraically. I highly encourage you to get used to using algebra. I know you're thinking, why? It was easier to just say plus 4, plus 4, plus 4 this way so I could get to my positive 4 right here. But the truth is, it's not that easy if you have fractions or if you have decimals or if you have different types of numbers. So I highly recommend to use the algebra situation. Let's go back to the book. You know what, before we go back, again, the two types of questions you're going to be doing, it's the same situation. You want to produce the a sub nth rule, right? They'll give you a list, and that's easy. You could identify a sub 1. You could find your common difference d, which is 6 in this case. Plug in a sub 1, plug in d, simplify, you have your a sub nth rule. Those are the easy ones. These are the slightly harder ones where they give you a certain value of a certain number on that list, a sub 5. All right, so you have to plug in the a sub 5 right here where the a sub n is at, plug in the d that they give you right here, where the common difference goes, do the math to solve for a sub 1, and then once you have your a sub 1 and your common difference d, you just plug those in here, and then you simplify, and actually I did it the other way. You plug it in right here like that, simplify, and you'll get that final a sub nth rule. All right, so that's what we're doing on our homework assignment. Page 670, numbers 20 through 23. So check out number 20. That one's pretty easy. They give you the a sub 1. You could find the common difference by doing 46 take away 35. If you look at 21, same deal. A sub 1 is really easy to identify. It's 31. Common difference is 3 take away 17, or 17 take away 31. It's 22 and 24 that are a little bit more challenging. You have to use algebra, where you plug in a sub 9. That way you could identify that your n value is 9 to plug in 9 for n. And then you plug in your common difference. You could solve for a sub 1, and then plug in your a sub 1 and your common difference d. All right, guys, good luck. It's only 4 questions. Good luck. You have your answers right here. We're doing the odd ones, so your answers are right there. Of course, all of this is on PDF on Edmodo.